students. Our topic is separation of variables, which is the first type of differential equation. Now, the standard form of a first order differential equation is m dx plus n dy equal to 0. Now, the idea of separating the variables, since both m and n are functions in x and y, you need to simplify this equation into this form: a of x dx plus b of y dy equal to 0, which obviously a of x dx term is already integrable and b of y dy term is already integrable. We have to remember always that the process involved in solving a differential equation is integration. Now let us solve an example. So this is exercise 7, page 25 of our textbook, which is Elementary Differential Equations, 7th edition by Begent and Rainville. So the given equation is y prime is equal to x times exponent the quantity y minus x squared when x is equal to 0 and y is equal to 0. So clearly there are initial conditions given. So this is an initial valued problem. Now the first step is to simplify the given equation, which is y prime equals x e raised to the quantity y minus x squared. We all know that y prime is a derivative of y with respect to x, as well as e raised to the quantity y minus x squared is just equal to e to the y times e to the negative x squared. Now at this stage, we can already see how we are going to separate the variables, okay? So we have dy over e to the y equals x e to the negative x squared dx. So at this stage, really, we have separated the variables. E to the negative y dy is simply simplifying 1 over e to the y dy. And we just copy the right side of the equation. Now integrating both sides. So we just showed you here how we perform the integration on the right side. So we just let e raise negative x squared as our u, and we get our du equal to negative 2x dx. Since we only have x dx, so we need a correcting factor of negative 1/2 to be multiplied to this term in order for this term to be integrable. So integrating, you will have the integral of e to negative y dy is negative e raised to negative y. And the integral of this one is negative 1/2 e to the negative x squared plus c. Okay, so I hope you already understand why we have a negative 1/2 here. As I've said, this is the correcting factor that we need to multiply to the right side of the equation in order for this term to be integrable. Now simplifying, we have 1 over 2 e raised to x squared minus 1 over e to the y. This term just came from the right side of the equation, which we transpose to the left side, and 1 over e to the x squared is just e to the negative x squared. Likewise, 1 over e to the y is just equal to e to the negative y. Now multiply both sides of the equation by the product of the denominators, then we get this equation. Okay? And I hope you understand that e raised to x squared plus y is just equal to the product of e to the x squared and e to the y. This is now our general solution. But since we have an initial valued problem, so we need to get the particular solution. What are we going to do with the values x equal to 0? and y equal to 0, or the conditions. We need to substitute these values to the general solution, which we arrive at 1 minus 2 is equal to 2c, because e to the 0 is 1 and 2e to the 0 is 2, so 1 minus 2, and 2c is just equal to 2c times e to the 0, and we get c equal to negative 1/2. Now what are we going to do with c equal to negative 1/2? We substitute this to c here, which if we multiply to positive 2, we have negative 1. So the next step is copy the left side, and we have negative e to the x squared plus y as a result of multiplying 2 and negative 1/2. Now we transpose this term to the left side and this term to the right side, which we get this equation. And from the left side, we have a common term e to the y. So we factor out e to the y, and what remains is 1 plus e to the x squared multiplied by e to the y, and we copy the right side of the equation. Now we attempt to solve for y, since this is the form that is used by the book. So we need to arrive at an answer similar to that of the book. Okay, so we have e to the y equal to 2e raised to x squared all over 1 plus e to the x squared. Now we get the natural logarithm both sides. So we have here natural logarithm of e to the y and natural logarithm of 2e to the x squared all over 1 plus e to the x squared. But ln of e to the y is just equal to y ln of e. We just copy the right side of the equation. But ln of e is just equal to 1. So our equation is now reduced to y equal to ln of 2e raised to x squared all over 1 plus e to the x squared. Now, if we divide both numerator and denominator of the right side of the equation by e to the x squared, then we get our final answer, which is y equal to ln of 2 all over e to the negative x squared plus 1, which is similar to that of the book. This is actually the particular solution because we have an initial valued problem. So I hope you understand the steps in this solution. I will be solving another first order differential equation, separation of variables, in the coming videos. So to all my students, please stay tuned. Thank you very much.